Ready? Okay, guys. Okay, well, good morning, and thank you all very much for coming to this session. Fabulous crowd. I've presented to audiences with as few as about 3 people. Not this week, though, so it's wonderful to see such an audience here. Generally, on the second and third days of a conference, I mean, this is only a 2-day event, numbers start to go down. You know, you either had enough, or you want to get back to doing some coding, or you want to get back to the office. It's still a little bit early at the moment, so I think it's wonderful to see so many of you here. Okay, so my name is Akmal Chaudhri, and if you can read Chinese, that's the same underneath. Anyone read Chinese, by the way? Okay, brilliant, fabulous. So the title of the talk is Considerations for Using NoSQL Technology on Your Next IT Project. My interest is in particular skills and looking at opportunities for, what technologies are doing well, what may be a good technology to get into, and then in terms of salaries, those kind of things. Those are all issues that I enjoy looking at and trying to find more information about. Market analysis, I think it's generally called. However, I have got some Java code examples as well, which I want to show you too. They very generously gave me, I think, an hour and a half, and I've got 200 slides. So you're going to have an awful lot of information in your heads by the time this session is finished. Okay, so let's get rolling. Okay, so there's the abstract. Don't worry too much about that. Just focus on the parts in yellow. Okay, so finding the relevant developer skills and choosing the right product. Not very easy to do, but I hope that in this session I can give you some hints, some advice, some directions, some things to look at when you do your investigations and you start to look at some of these products and technologies yourselves. Could I just have a quick show of hands? How many of you are actually actively looking at NoSQL database systems at the moment? Okay, a fair number of you. All right. How many of you are looking at Mongo? Okay, almost the same number of people. Anyone looking at Cassandra? Okay, a few of you, all right. And then I think the rest, Neo. Anyone looking at Neo4j? Some of you, all right. So I think that kind of gives me and that, by the way, is fairly typical, as you'll see a little bit later on in terms of the presentation, that, Mongo leads the way, Cassandra is kind of number 2, and, the rest kind of the long tail, as they say. So, all right. Okay, so there we go. So in a packed program, here's the rough agenda. So what I'll do is I'll do a little bit of an introduction, market analysis, which I think is useful. You will need to understand what are the market forces at play at the moment, who is doing well, looking at jobs, salaries, these kind of things. For you as developers, and I assume most of you are developers. Anyone not a developer? Any CTOs, CIOs? Okay, business analysts? Anyone in the wrong conference? Okay, that happened one time in the Philippines a few years, I don't know, maybe 10 years ago. So I was presenting on DB2, and then there was a conference next door talking about waste disposal. So what happened, people from next door had got into the wrong event. So I was talking about DB2, they had no idea what I was saying, and then we kind of found, but okay, I can tell more about that offline. All right, so other things. Then we'll look at NoSQL. In detail, okay, and as I said, I've got some Java code to show you from various different products. And then there's a whole range of other issues which we'll very, very briefly touch on, simply because we don't have time today, but I think are very important. So things like security and benchmarks. When you evaluate these products, probably you will do your own, which is the right thing to do. However, there are some results and publications out there that you can look at to give you some sense of what these products are able to do and how they behave. Very briefly on analytics, very briefly on what alternatives there are for NoSQL as well. So they talk about things like NewSQL, for example. We'll say something about that. And then summary and resources. And by the way, for this slide deck, I have about 30 to 40 slides at the back, just full of references and links to various things that I found useful over the last 1.5 years or so. So when I provide the deck to the organizers, and my thanks to CodeCentric, by the way, for inviting me, that you will be able to download the deck and have access to all of that information yourself, okay? Okay, so my background, just a quick slide on who I am. So I've done a little bit of everything. I've been a developer. I worked for Reuters in London. I've been an academic, City University, doing research on database performance benchmarking, worked for Logica as a consultant, technical architect for Computer Associates, worked for Informix. And then, sadly for me, Informix got bought by IBM, you know, a long time ago, maybe 11, 12 years ago. So that's how I ended up at IBM. And then just very recently, a couple of months ago, I joined Hortonworks as a technical instructor, which is the role I now hold. So as you can see, it's fairly broad industry experience. I've done a little bit of everything in my professional career, worked with a variety of technologies, different programming languages, primarily C++ and Java, lots of community outreach, lots of books. And by the way, these books make wonderful gifts for your friends and loved ones. So I get a check for $25 every 6 months, so I still have to keep the job at Hortonworks. Okay, so go back in time a few years. I think this may be about 4 or 5 years ago. There was an event, the first of its kind that was held regarding NoSQL database systems. And here is the abstract from that event. So it says, you know, have you run into limitations with traditional relational databases? Don't mind trading a query language for scalability, or perhaps you just like shiny new things you want to try out. Either way, this meetup is for you, okay? So this was the very first meetup that was arranged. And I think at that time, people were starting to think about alternatives to relational for certain types of problems, which they were seeing in the real world, and then finding that relational technology was not the best suited for it, and therefore wondering what they could do, how they could address that. Some people started to build their own systems, and then over time we've seen a great explosion in these NoSQL database products over the last few years. Interestingly, some of these products have actually been around for a very long time. I mean, look at Neo4j, for example. They claim that it's been in development for 10 years. So, you know, there are things that people have been working on for a long time. Okay, more about that soon. All right, so here we go. Anyone know what one of these is? Okay, I'll give you a clue. It's called an autostereogram, all right? Very popular when I was a young man. So you used to be able to buy books, entire books on these things. So you look carefully and deeply at the image and you see a hidden image. And I promise you this will work either on the screen or on a PDF file. It's exactly the same. Now, so in your own time, when you have a chance to look at it, see if you can find the hidden image, okay? So my goal here is to help you try to see things a little bit more clearly, okay? And decide whether NoSQL is something for you. Whether it's going to be useful to you, possibly, okay? Possibly not, depends what your use case is, what the business problem is you're trying to address. Let's look at a little bit of sort of market analysis in terms of Gartner. Probably many of you have seen this type of thing. It's called the Gartner hype curve, okay? So often technology follows a particular cycle. Something starts off as a technology trigger down in the bottom left-hand corner there. Somebody's got an idea, an itch, you know, there is some business need. They start off and try to find a solution to that. And then over a period of time, you know, lots and lots of interest is generated, lots of companies get in on the act, start to build things, and then you get this peak of inflated expectations because people feel the technology is going to solve all their problems. It never happens, okay? And then they get disillusioned. That's where this trough of disillusionment is. And then slowly they realize that, okay, you know, it's not going to solve all my problems, it may solve some of my problems. And then you get this point, plateau of productivity, where over time the technology has matured. It's in that situation where you can use it to help you with certain types of problems, and there is good skills available, good tools available, and all the surrounding ecosystem that goes with that. Okay, so where is NoSQL at the moment? Still very early days, okay, still very early days. So it hasn't reached that point yet where it's, you know, peak of inflated expectations. People think it can do everything. Not quite. Another way of looking at this is something called this innovation adoption lifecycle. And I apologize, I know the colors are a little bit washed out there, but what we have is this kind of bell curve. Entire books have been written about this. So you have this notion of innovators, early adopters, early majority, late majority, and laggards. And typically for a lot of new technology, it tends to be the first two, okay? So the innovators and early adopters, And then you have this thing called the chasm, which needs to be crossed in order for some technology to become mainstream, widely adopted, widely used. And unfortunately, I think at the moment, certainly we haven't seen that with NoSQL, NoSQL. So it's still early days. I think it's still very difficult to say whether we've reached that point or not. Market is still very, very small. Certainly lots of hype and lots of information out there, but hopefully, as I said, you'll be able to pick up some useful things today. All right, let me just remind you something. Lots of you are very young, okay? And maybe if I say 20 years ago, you'll say, too young, don't remember. I'm an old guy, gray hair, going bald. So I remember the time when we had object-oriented databases. They were going to be the next big thing. And so 20 years ago, here was the prediction about OODBs and how fast they were going to grow, a business worth $1.6 billion by the year 2000. Never happened, okay? 10 years later, here's what they said about XML databases. It's going to be, $700 million by the year 2004. Never happened. And surprise, surprise, here's what people say about NoSQL. So it's 2016, which is a couple of years away, okay? So let's wait and see what happens. So, depending on how you measure these things, it could well be, we might see these type of numbers, we might not. It's hard to say at the moment. I think too many variables, too many things that may affect it. Now, the other thing which I often see is that whenever these kind of new technologies come along, they always say it's the way developers think. So 20 years ago, when I was doing OODB performance benchmarking research, the thing that I used to hear about is that OO, object orientation, is the way the developers really think, okay? 10 years later, it was XML. That's the way you really think. And today, of course, it's NoSQL. Now, anyone really thinks that that's how you think? I mean, you guys know more than I do. I used to be a developer one time, but I've kind of moved on, do other things at the moment. Maybe, I don't know. It's one way to kind of look at things, and again, I'll show you a counter-argument to that very shortly. All right, something else which tends to get shown a lot is something like this, okay? You'll see lots of these types of diagrams, and by the way, I really bought that Lego and really made that car and really took that picture. So now, okay, so we had the arguments that with object orientation, you're just dealing with the objects. There's no need to disassemble it, no need to put it into different tables. There is a cost in terms of joining it, reconstructing your original object. And then if you've got millions and millions of these, as you know, those of you who've worked with the relational system, joins are expensive. You want to try and avoid them as much as you can. But the thing is that, relational technology is very mature. It's been around for a long time. Cost-based optimizers, people have invested so much time, effort, into building these systems that they are really, really very smart today. Okay, so how is this thing with XML? Surprise, surprise, exactly the same arguments. Okay, so it was that you can't store documents in a relational system, you have to decompose them. Now, what did the relational guys do? Well, in the days of objects, they added object support, okay? So you could write Java UDFs, you could extend the system, and similarly with XML, you can store your documents directly in a native, using a native XML type, rather than having to shred it, as they used to say, store it in multiple tables. And of course, I see exactly the same argument today for NoSQL. Let me remind you of this though, okay? As long as it's in a relational system, you have a lot of flexibility, okay? You're not just going to be able to query in one particular way. Maybe you want to query a different way, or you've got a different business use case, or you want to find different information. And you can do that. Often with a lot of these technologies, such as NoSQL databases, okay, your access paths, if you like, the way that you're going to query the system is fixed. You've decided that there is something you want to get really, really fast. It's hardwired, okay? That's the way you get to the data. That's the way you get to run your queries. The thing with relational is you get flexibility, okay? You may not know what you need to, what your customers or your users may want to find tomorrow, or 1 week from now, or a year from now. So you build your systems in a way that tends to give you that flexibility. Okay. Now, here we go. So a lot of NoSQL products, okay, so they talk about this thing called impedance mismatch, right? So it's this idea that your programming language is one thing, the database understands something else. Whereas what they tend to do is to provide you with the same language in order to do the querying. and access of your database. And again, the Java code examples I'll show you a little bit later will highlight those issues. So there's an awful lot of focus on developer productivity, which is a good thing. It's not bad. Developers are productive, they are happy, they'll do the job better, they'll do the job faster. You can deliver your systems much faster, hopefully to a higher quality, a higher standard as well. The thing is that we tend to have lots of other stakeholders on projects. It's not just one group of people. And what worries me is that we tend to focus far too much on developers and their productivity and how easy it is for them, but we forget everything else. And so I'm kind of concerned about this issue, and I don't see too much being discussed about this at the moment. So things like tool support, or if you're a business analyst, or you're a manager, or you're somebody else, how can you get access to this information in an easier way that's more useful to you to help you with your business decisions, rather than simply worrying about, yes, you can build your system much faster because your developers will like it. Okay, something to think about. All right. The other thing is that for sure, you can download these products and you can start coding in 5 minutes. Typically, if you get yourself Mongo, for example, you can have it installed and running in a couple of minutes, and you can be happily coding against, your favorite programming language, or using the shell to do some development. What you need to remember is that these products are actually very complex pieces of software, okay? They are evolving, they are developing, they are improving all the time, and therefore it may take quite some time before you have the knowledge and the skill available to be able to use them very effectively, okay? And again, keep that in mind, okay? So React, for example, is a key value store. There's a particular project, people were working on it, took them 1 year before they were able to really use it effectively. There's another thing there in the middle. There's things I wish I knew about MongoDB a year ago. So understanding these products is key to being able to use them effectively, and that takes time. Last one, I'm learning Cassandra. It's not easy, okay? So there are people out there who've actively used these products and come across issues, problems, and again, keep that in mind, okay? I'm trying to give you a balanced view, not to just say, it's going to be great, solve all your problems. It may do that. But at the same time, you will have to invest time and effort in order to learn these products, use them effectively, find the right use case so that you can use these products to really help you in your business. All right, so plenty of hoopla and hype. So here we go. So here's one. Okay, so NoSQL attacks, okay? It's the next big thing. It's the end of relational. All right. Sexy NoSQL model on page 3. Anyone read the Sun newspaper in the UK? Okay, if you know about the Sun newspaper, then you'll get the joke. By the way, would you like to see the sexy NoSQL model? Here you go, for the ladies. And maybe some gents. I don't know. Who is that nice guy? I don't know. And if you're for the gents, I'll show you this. Okay, that's Bender, by the way, from Futurama. So that's robot porn, apparently. He's looking at something he shouldn't be looking at. If you're an electrical engineer, maybe you can understand those symbols. Okay, so lots, and by the way, I got loads and loads of these, but no time to show you them today. In the full slide deck, you can have a look at that. So plenty of hype, lots of articles, lots of things that people are writing. And sometimes I just worry because journalists tend to write stuff and it makes you think, okay, I really should be looking at this. Let's see. We've been there before. Past proclamations of the imminent demise of relational technology. So a long time ago, people were saying that object databases were the next big thing, okay? Gemstone, object store, objectivity. Then it was in-memory databases, times 10, SolidDB, persistence frameworks, XML databases, column stores. Today, of course, is NoSQL. Now, I don't want to take away anything from these products or technologies. These are great. There are certain problems for which each of these is going to help you. There'll be situations where relational is no good. I mean, relational is great. It's a general purpose database engine, good for a vast range of problems, but there will always be certain situations, specific problems that it will not be good for. That's the key thing to remember. And then finding what the right fit is for you, that's the important thing. Okay, so let's look at some market analysis then, okay? So just give you some more background here. Now, the thing to remember is that most of these companies, the likes of Mongo and DataStax and Basho and others, they are privately held companies, okay? So they don't publish any results. We can't get any kind of information in terms of how profitable they are. We just get some estimates in terms of revenue, which could or could not be useful. I mean, that just simply tells us how much money they're making, not how profitable they are. Enormous amounts of venture capital being invested in these companies, and again, that worries me a lot, because the thing is that, you know, the venture capitalists are putting this money in. At some point in time, they're going to expect a return on that money. So Mongo, for example, announced something like 150 million US dollars recently in terms of a round of funding that they were able to get from various organizations. Keep in mind, though, that IBM spends $1 billion every year on open source in one way or another. Microsoft is actually contributing tens of thousands of man-hours now on open source technology, okay? So when you look at those kind of things, this figure of 150 kind of just, you know, it's a drop in the ocean. Yes, it's big relative to, you know, what the sizes of these vendors, but keep in mind that venture capital funding, you know, it's only going to give you some indication of where the money is going. But as I said before, if I invest in a company, I'm going to expect some return on that money at some point in time in the future. And at the moment, from what I understand, and again, this is just a personal view, none of these vendors are actually making any money, okay? Keep that in mind. Let's look then. In terms of market size, then this is revenue, all right? So who's doing well? Well, Tengen is doing very, very well. DataStax is number 2. And I think generally you find in any particular technology area, there tend to be, you know, 1 or 2 companies that do really well, and then everybody else makes up the numbers. And then certainly for NoSQL, it seems to be that Tengen and DataStax are number 1 and number 2, and the rest are sort of, you know, not immediately there, but certainly a part of the long tail. Okay, now, jobs. Let's look at jobs, job trends for you as developers. Very important, because, you know, if you're looking for your next great opportunity, or if you're doing contract work, perhaps you're looking at the chance to move into something, then you need to get some idea of what's happening out there. This is from a US website, maybe not so important for us here in Europe. Can anyone see what's wrong with this chart? So you can see this enormous spike in terms of growth on the right-hand side for a whole range of these NoSQL products, which effectively began from about January 2010. If you look before that, it's flat. There's nothing. But can you see what's wrong with this? Anyone can spot what's... Absolutely. Well spotted. Okay, so as the gentleman says, this should be a red flag for you. Look at the scale. All right, it's 0.1%. All right, so the graphs look amazing, you know, huge number of growth there, but the actual number of jobs is absolutely tiny. All right, now let me give you some indication of the position in the UK. All right, and I'm sure here in Serbia you have websites that you can go to check for trends in terms of jobs. Okay, but this kind of mirrors what we generally see elsewhere. So Mongo is doing pretty well, you know, about over 900 jobs there. Cassandra number 2. Redis, HBase, CouchDB, Hive, Couchbase. So on the right-hand side, the top chart, you can see the graph is kind of going upwards, 2.5%, 3%, and growing steadily over time. The column chart below that is in terms of salaries, so reasonably well-paid jobs. You know, these are 40,000, 45,000, 50, 55, 60K. Those are pretty good salaries in terms of the positions that tend to be available as far as that histogram is concerned. So not bad. Other ways we can do some analysis. LinkedIn, maybe less useful. So this is from 451 Research. So again, you can see here on the extreme left-hand side, Mongo doing really well, Cassandra number 2, and then I think gradually tails off, Redis, HBase, CouchDB, and so on and so on. And then again, if we look at this in terms of kind of a donut, the big blue is Mongo. But here's a different way that we can look at some of the data here. This is Google Trends, all right? So on this chart, certainly we can see that over the last 12 months or so, you know, React not doing particularly well there. Couchbase right at the bottom there, the red line, no movement at all. What seems to be gaining some interest is certainly Cassandra and Redis. And then if we compare this to some relational systems, so the blue line right at the bottom is Mongo, so above that you can see things like Firebird, Sybase, SQLite, Postgres. Those are doing quite well. And then let's put this into context. basically everything disappears when you're looking at MySQL and Oracle. So definitely those are still the key skills. Here's another way to look at the data. So the red is Oracle, green MySQL, blue SQL Server, and so on and so on and so on. And then down at the bottom there, you can see in gray is the top 9 or so NoSQL products, which accounts for about 6% of, certainly in this website, DB Engine's ranking. So what this site does is it takes about 5 or 6 criteria. How many times, for example, does it a particular product appear in someone's LinkedIn profile, how many times when we do a web search do we get that? So they kind of arrive at a weighted number that gives you some sense of popularity. And again, if we drill down and look at that 6% in terms of NoSQL, again, you can see that Mongo is doing really well, the big red chunk there, Cassandra in green, and Redis, and so on and so on. Pretty small in terms of overall numbers. One other way we could look at this is in terms of a hosting example. Okay, so these are numbers from Gelastic. And by the way, I tried to find these type of data and numbers from other hosting services, and I contacted a few of them, but they said we don't publish these types of figures. So there's nothing particularly, this is just a single set of a single sample size, if you like, and therefore, take it for what it's worth. So again, if we look at this, we can see that MySQL is doing very well, overall. There's no particular decline in its use. And if we look at CouchDB and Mongo on this particular chart, we see them doing okay, but not particularly growing, okay? So keep that in mind. So, I hope take all of those charts together to get some sense of direction. Often the vendors are very selective. They'll give you 1 or 2 charts that happen to show their product doing really, really well, but they don't show you anything else, okay? It's called marketing. And you can't blame them. I mean, they're out to sell the technology, out to win customers. So I hope that this gives you a bit more knowledge to go armed to them. All right, so let's move on. Let's look at NoSQL. So originally, I think it started out as a movement where people just wanted to get rid of SQL altogether, which is understandable. I've worked with it as well. It can be difficult, especially if you're working on a project, you're doing a lot of coding, say, in one particular language, whether it's Java or C++ or something, and then you're having to work with SQL in an embedded fashion or a dynamic fashion against a particular relational database. It can be a pain. I think more latterly we see that it's changed from getting rid of SQL altogether to saying not only SQL. In other words, can retain SQL if you want, but let's have other ways that we can also access the data that we need. Okay, so why did these systems arise? Well, some applications need very few database features but need high scale. Scalability is something that they talk about. Scalability in terms of horizontal scaling, so just adding additional off-the-shelf servers, things that you can buy readily, SATA disks, and being able to throw these machines at your particular problem. You want to avoid data or schema pre-design for simple applications. Okay, this kind of fits in with this whole agile movement of being able to build things quickly. Low latency, low overhead API, use the language that you're programming in. So if it's Java, you code against Java, against the NoSQL database. If you're using C#, it's C#, it understands. There are drivers available for various different languages. And again, simplicity. You want to keep things simple. You don't have a particularly complicated need. So you don't need fancy indexing, for example. Just fast lookup, often by primary key. Here's a survey that was done some years ago by Couchbase. Okay, so they asked some people out there, what are the main reasons that you really want to use a NoSQL database? Number 1 reason, lack of flexibility, rigid schemas. Okay. Secondly, inability to scale out. Thirdly, high latency, low performance, and then a few other things like costs, all of these or other reasons. So you can see that these are the kind of things that people have pain points about relational, and therefore it's difficult to do certain types of things with relational technology, and even perhaps it wasn't designed for those types of problems, and then people are looking for alternatives and then adapting or adopting NoSQL products to help solve those types of problems. Something else that's often mentioned is this notion of big data, variety, velocity, volume. Here's some data from an IBM survey that they did with University of Oxford in the UK a couple of years ago. And in fact, this sample size, I think it was 1,000 companies or more, 42% of respondents said that they were actively looking at NoSQL engines as part of a solution to their big data problem. So you can see, that's nothing to sneeze at. 2/5 of companies actively investigating or already using something related to NoSQL. Okay, I think this slide, let me skip this. Very, very quickly, let's show you this. You'll often see this. No presentation on NoSQL is complete without some mention of this, CAP theorem. Consistency, availability, partition tolerance. Pick any two. You can't have all three, apparently. And I think, I don't know if it's been mathematically proven. Certainly there is a proof out there that shows it. But if we kind of superimpose a number of products, popular products upon this graph, then we can see where they tend to sit. So again, you have some differentiators, some different behavior, how these products handle certain types of problems. So the graph database is Infinite Graph, Neo, ACID compliance, what we tend to think of in terms of traditional relational systems. Then you have this notion of base, which again we'll discuss very briefly. And then I put a question mark on the right-hand side there, but in fact it's also ACID, or can be. I need to look further into that. Okay, so ACID versus base, atomicity, consistency, isolation, durability, what we tend to think of with relational systems. Base, basically available, soft state, eventual consistency. Okay, this is a very important concept. I think the Dynamo stuff that Amazon originally used as part of their systems for handling customer orders, quite important. I think Pavlo may have mentioned this in his presentation. Certainly he's done so before when he's talked about base, is this idea that, what's the most important thing if you are Amazon? You do not want to lose a customer order. Okay, that's the most important thing. But given that you have a large distributed system, it's possible at certain times that parts of that system may be down. Therefore, this notion of eventual consistency, that eventually the system will become consistent. And therefore, that's quite an important concept. That concept has been taken further by a number of these products. Okay, so here we can see a kind of comparison based on a paper by Eric Brewer, who is, I think, advisor to Google. He's a professor as well, does a lot of this stuff. This is from the year 2000. So we can see there are important similarities, important differences between the two, and their focus is very different. The other thing to remember that if you're going to, and I believe there's a gentleman who's going to be speaking later that, we live in a base world. I think there's a presentation to that effect. So it's worth attending that as well and trying to get a better understanding of this. That these products are tunable. This whole idea of consistency, eventual consistency, is very tunable. You may be prepared to wait a very, very short time, or you may be prepared to wait a longer time before your whole system eventually becomes consistent. So there are things that you can do, particularly Cassandra and React. I think these are the two best examples where you can tune and tweak these things, it's entirely possible to configure them to your requirements based on what your needs are. All right. Important thing to remember, and please don't try to read this, okay? This looks like a map of a subway system for some big city, and if first glance, if you look at this, it does in fact look like that. But what this is meant to show is that there is a huge world of products and technologies out there of which NoSQL is just a very small part, okay? Lots of relational and non-relational systems, and on this chart, the NoSQL guys, they just make up a very small proportion of that. Okay, so this is from 451 Research. How many of these systems are out there? Well, there are an awful lot. Here's a quote from Jeremy Zawadny. What he's saying, there are lots of key value stores, distributed schema-free document-oriented databases. They're springing up like weeds in a spring garden. And folks love to blog about them and talk about how their favorite is better than the others, or MySQL, which is absolutely true. He's spot on. So there is a website, NoSQLdatabase.org, which kind of tracks the number of different products. Lots of key value, tuple stores, object databases here are classified as well, document stores, graph databases, wide column stores, XML databases, and lots of other products as well. I think this number is over 150 out there, with new ones appearing all the time. Now, it's important to keep an eye on this because some of these products end up being part of the Apache effort. So things like Cassandra, for example, is an Apache project. CouchDB, I think, as well. And then some other things, if you're going to be working in the Hadoop space, I think there are others as well which could be very important too. And it's worth just tracking what's out there, what's up and coming, and the new stuff. Now, the general consensus seems to be there are 4 main types or 4 main categories, okay, of which here are a couple of examples. And if we briefly look at these this way, we'll discuss these in a little bit more detail very shortly, okay? So document stores, effectively you're storing collections of key values. Column stores, somewhat similar to relational systems, I guess, but we talk about this notion of column families. Key value stores, binary data, and then these graph stores, keys and properties of nodes connected through relationships. The relationships themselves may have some properties as well. These remind me very much of object-oriented databases, and in fact, if you've used any OODBs, I think you move to a graph database, you'll be, I think, quite surprised by the similarities. Here's a nice way to look at this. So this is from a gentleman called Ilya Katsov, who did some analysis of this to kind of put these into position. The goal here is not to show that one is evolving into another, but just simply to show that on the left-hand side, key values are the most simple types. Then we've got ordered key value, big table, which we tend to think of things like Cassandra, the document stores after that, you know, the likes of Mongo and Couchbase and CouchDB, and then graph stores, which tend to come from a different branch of the evolutionary tree. Okay, let's have a look at a bit more detail now, some of these products, and then give you some Java code to chew over. So document stores, rich hierarchical data structures, reducing the need for multi-table joins, okay, could be very useful if you're storing lots of complex and deeply nested documents. Structure of the documents need not be known a priori, okay, you don't need to know about the structure in advance, but your query language typically can understand the contents of a document. So this can be very useful in situations where, for example, in a relational system, you may end up with lots of null fields or information that's just not there or missing or something like that. In a document store, it doesn't matter. You store what you need to store and no more. And then your query language typically understands what's available. So if you're trying to query over a large collection of documents where some of the fields are missing, you know, it's okay. You'll just get the results back for what you're expecting, okay, in terms of those fields where there are some values that you can use. Typical use cases, rapid ingest and delivery for evolving schemas, web-based objects. So, okay, a couple of examples where it's good for. Okay, let's have a look at some Java code. So, in terms of a connection, very simple to do, okay? So just point it to the database, point it to a particular collection, okay? Collection kind of analogous to a table. And then very simple, you know, we just use a Mongo client. This one is running on localhost port 27017. Give it the database name, give it the collection name, and we're connected. It's as simple as that, okay? Standard Java, very, very easy. How do we create a new object? Well, all we do is just get ourselves a basic object. And then here we've just got an array. So I want to add a list of things that I like. Satay, kebabs, fish and chips. Okay, that's why I'm rather big. Then maybe want to store some other information, such as my name, my age, you know, what's today's date, and then storing that set or list of things that I like, and then we just say collection.insert. It's as simple as that. So you can see this is very, very clean. Okay, I mean, if you're a Java programmer, and you can do the same, you know, if you're working in PHP or C# or whatever, it's the same thing. You try to make the thing look like the language that you're working in, and it's very clean. There is no need to learn a separate language. How do we read this? Well, Mongo uses this notion of a cursor, okay? So it's very familiar. If you've worked with relational systems, it's the same sort of idea. Basically, you get a cursor, you have a loop, you iterate through, do something, maybe pull some things out of that, process the data, and then just close it at the end. This one's a very simple one because there's only one record in here, and all I'm doing is simply output to the terminal, so it doesn't actually do anything. One very important thing here is that those of you who've worked with cursors and relational systems, you'll know that sometimes it's very easy to run a query not thinking too much about what you're trying to optimize, okay? But you're thinking more in terms of the result set that you're getting back. And so you can pull across an enormous amount of data from your server to your client. So some time ago, last year, when I was doing a little bit of work using Mongo, it took me about 15 minutes to run a query. And then I thought, this is not right. What am I doing wrong? What I was doing wrong is exactly what I just said a few moments ago, pulling the data across from the server to the client, iterating through, it's a nested, so you have an inner iteration and an outer iteration, and then doing some processing for that. And that query was taking 15 minutes to do. Changing that, having the query run on the server and then simply ship the results back to the client, it was less than 2 seconds, okay? So vast improvement. Very easy to think about these things, and then just, you're not quite, you need to understand how these products work again. Having that knowledge, being able to know what it is you can do on the server, have it shipped to the client, I think all of these things can make a big, big difference. Updates, okay, so what I want to do is to change my age from 40 to my real age of 29. Here's how we would do it. So, okay, so we just pull the existing document, and I can query it on my name. Okay, this one assumes that name is the sort of unique property. No one else in that database has the same name. It can be enforced using an index as well. Okay, a unique index, you can do that. Very similar to the idea of relational systems, same thing. And then just changing the age to 29. I use the $set operation here to update my document, and then write it back out into the collection, okay? So it does the update. And then delete, very simple, collection.remove. So I find what it is I want to delete, and then just ask the system, take it out, okay? So very, very clean. Any of you working with Node.js here? Okay, a couple of you guys. Well, it's the same kind of thing here as well, very clean, okay? So here I'm using async, okay, just to keep everything synchronized, so it's not doing the output to the screen before it's actually run something, because I've got messages that I want to appear on the screen as well. So again, just do a connect, and then we need to do a little bit of error handling here, and we've got the same collection, exactly the same structure. You can see it's name, age, date, a list of things that I like, foods that I like, satay, kebabs, fish and chips, and again, create collection.insert. Okay, in this case, I hard-coded the values rather than using variables. And find one. In this case, I'm not using any iteration or any cursor, just directly asking it to find me that particular record. And then here, do the update. Again, you can see it's very, very straightforward. And then finally, just delete. Again, can just remove it. One thing I have to say about Mongo, any of you taken the free Mongo courses? Some of you, okay. Those are pretty good. And for those of you who have not heard of them, I'd highly recommend you take a look at those. The one thing that I have to admire 10gen MongoDB Inc., as they're now called, is that last year they started offering these free training courses over 7 weeks. You do quizzes and lectures each week, and then at the end they give you a test. You pass the test, achieve 65%, I think, is pass mark, and they give you a certificate. That, it's not an official certification, but what it is that you've taken the course. And I think they've had over 100,000 people registered, 100,000 developers and others registered for those training courses. So very, very smart move. That's partly why earlier on, when we were looking at those charts in terms of skills, the numbers are so skewed in favor of Mongo, because what are people doing? Well, they're taking these courses, and then what's the first thing they're doing after they passed? add it to their LinkedIn profile to say, I took the Mongo course, I now have Mongo skills, and that's why those numbers are so skewed in favor of Mongo. Okay, quickly then, moving on. Column stores, multiple attribute access. We've talked about this notion of column families. So each storage block contains data from only one column set to provide data locality for hot columns. Okay, very useful if we're going to be doing certain types of queries where we want things that are associated together to be grouped together and stored together. Column groups defined a priori, but support variable schemas within a column group. Okay, so lots of flexibility, much more so than a relational system. And typically these products, such as Cassandra and similar products, scale using replication, multi-node distribution for high availability. Okay, so you can have these large clusters, large distributed systems worldwide, very much optimized for writes. Okay, so you get real performance gains if you're doing lots of writes, good for throughput, for high throughput verticals, activity feeds, message queues, caching, web operations, so on. Let's have a look at a little bit of Java code. So this is using the old driver. I need to update this because they've announced a new one. But again, if you've worked with JDBC, this will look very, very familiar to you. So we just do our connection, point it to, in this case, localhost port 9160. DemoDB is the particular system that I'm accessing, and then I'm in. You know, it's just a couple of lines to connect. How do we create something? So here's an insert statement. Insert into people, name, age, date, likes, values, okay? And then give it some values. What does that remind you of? SQL, yes. Okay, but it's not. It's called CQL, okay? Keep that in mind. It's the Cassandra query language, not SQL. Very similar. There are some important differences as well to keep in mind. And I mean, here, for example, select star from people, just get me everything from there, and then just use a cursor. Very similar to the way that we do things with a relational system. Okay, just close our cursor, close our statement. We could do some processing there as well. Update, very similar. Update people, set age equals 29, where name equals, you know, and the same thing. And then delete from people where name equals. Okay, so these basic operations, SQL-like, I think, you know, the query language is, in the sense, in one sense, it's useful because if you're already familiar with SQL, then I think adapting to the CQL is going to be a lot easier for you in terms of transition. I forgot to mention with Mongo, there is a couple of query interfaces that they have. There's this aggregation framework that they have as well. If you're familiar with Unix, familiar with pipelines and how they work, that is something I think you will find is very, very easy to use. But the thing is, keep in mind that with these products, the way that you're interfacing, it's usually going to be through the programming language, but there is some query support as well. And you can do queries, and the nature of the query language is going to be often very different from what you're used to if you've worked with relational systems. You're going to have to learn something new. That's the way it is. Quickly moving on, key value stores. These are the simplest NoSQL stores. Low latency writes, single key value access. Store data as a hash table of keys where every key maps to an opaque binary object, okay? Easily scales across many machines. Use cases, typically where you've got lots and lots of simple data, things like sensor data, for example, or in those situations where data are changing rapidly, such as stock quotes. And my favorite is this one, Redis. I like this a lot because when I downloaded it and I started to play around with this, I was amazed how easy it was to use. So here you are, here's the Java, sort of 2 lines, you know, 2 lines to connect. And this is using something called Jedis. Localhost 6379, so create, again, same information. Now, the thing is that with a key value store, how do you model things like complex structures? Here's one way we could do it. So at the top there, what I'm doing is using this thing called global next user ID, okay? So it's a unique identifier, system-wide, I think. Just increment that, okay? So to get the next one. And then I can build up a structure, so I can say things like UID plus ID plus name, fill in the name field, UID plus ID plus age, filling the age field, similarly for date. And then this is a nice product because it supports things like sets. So I can add members to a set. So my satay, kebabs, fish and chips, I can add those into a set. They are now part of that set. And how do I read this? Last line at the bottom, the H set, okay, very last line. What I've done there is rather than having to figure out what is this ID that I'm using, I can associate it with something more meaningful to me. So I've said, okay, assign this UID to this string called Akmal, and I can use that string now to find the ID, and it's something more meaningful to me rather than having to worry about the ID. And I use that here in this next example right at the top. So I just say UID lookup name, Akmal, get me whatever that ID is. I'm not interested in the value. And then using that ID, again, I can retrieve the name, the age, date, the likes fields. Okay, so here's how one way we could model complex structures. Update, again, very simple. Just find that, use the hget at the top, the first line, and then use the set operation there to change the value of the age to 29, which is the field in terms of updating the age. For delete, again, very, very straightforward. There are delete operations, so just find what, the record, the different parts of it, I delete one by one. So get rid of the name, get rid of the age, get rid of the date, and then that set that has the things that I like, again, just delete that in one operation. Okay, and one nice thing, by the way, about this particular product, it's something like a 800 kilobyte download for Windows. That's how small Redis is. Fabulous product. Have a look at it. I mean, it's really, really nice. I like it a lot. Okay, graph stores, nodes, relationships between nodes, key value properties. So typically, you're accessing data using graph traversal. So you find some entry point in your graph structure. You're navigating these structures. Neo4j, for example, has something called the Cypher query language, which you can use. Very good for associative data sets, very good for reasoning on complex connected data, inferencing applications, healthcare, government, telecom. I think the likes of telecoms are big users because it's very easy to model their networks using this type of technology. Social networks as well. Here's my LinkedIn profile. By the way, one thing about this isn't stored using a graph database. It's actually relational, but just to show you one kind of application that could be very useful. I mean, this is not a particularly big graph structure, but if it's a huge graph structure, perhaps you want to navigate these, the links between nodes. There's certain types of queries that you want to run. Could be very useful, modeling it that way. Okay, so again, if we look at a little bit of Java code then, a little bit more involved with Neo. So this is on Windows. Just point it to the path for the database. Then I've created an enumerated type called likes. There's a little bit of work there that I need to do in terms of setting up this path and then registering a shutdown hook. But then after that, I'm connected. And then in terms of creating something, here we've got transaction boundaries. Okay, so we're doing things inside a transaction. We define the start and the end, and if something goes wrong, we can do a rollback or just handle the problem in some way. So what I'm doing here is simply create one node, call it first node, set some properties for that, create a second node, set some properties for that, and then create a relationship between the two, link the two together. Again, very simple example. You can imagine how you could use this in more complicated situations where you're building up a very large network. How do I read this? Just find the first node, get its properties, get the second node, retrieve its properties, and again, all within transaction boundaries. How do I update something? Find the first node, change the property age to some new value here, commit it, and again, it's done. And then delete. What I need to do, I need to find the first node, I need to get the second node, and I need to get the relationship as well. So what I'm doing first is removing the relationship, then removing the first node, removing the second node. So those of you who've worked with object-oriented databases, again, this will be very, very familiar, very, very similar in many ways. Okay, so some typical use cases then. Online mobile gaming. How many of you are doing that kind of stuff? Mobile gaming, online stuff. Okay, few of you. Surprised, okay? That seems to be a big use case for this technology. Things like dynamic placement of visual elements, persisting user state, persisting user-generated data, advertising, ad serving, ad matching, again, seems to be a good use case. Some of these, I think Aerospike is the product that comes to mind. It's a key value store used for a lot of this type of application. They've got some customers around the world doing this type of thing. Very, very fast, extremely fast. Other things, news and media. The Guardian newspaper in the UK uses Mongo, for example, for certain applications. I think they had a very painful experience over a long period of time where they're trying out various new technologies, finding out that they didn't work particularly well. Eventually, I think they were using Oracle, and then when they found that didn't work, they switched to Mongo and now have something called a Mongo first policy, apparently, which means that for each new project, they will look at Mongo as the database technology of choice. It's a policy some organizations use. I've worked with customers in the past, for example, who said, we'll do nothing but use DB2 for everything. But so it doesn't surprise me. Other things, product catalogs, device provisioning. Typically, the kind of use case requirements these organizations have is schema flexibility and development agility. Okay, so this agile development, the ability to change things rapidly in your schema, adapt it to changing business needs, these tend to be the biggest reasons that people want to use this. And again, because you're able to drive things faster, you're able to make the changes faster, it's important in today's world where competitive pressures are so strong. You can't stand still. Deregulation in many industries as well is another issue. And so really you're always being pushed to respond rapidly to changing business circumstances. Other things where consistent low latency, even under high load, millions of users. So some of these products, for example, are used in gaming applications where you've got millions and millions of users around the world, all working, all doing something at the same time. Dynamic elasticity, rapid horizontal scalability, ability to add or delete nodes dynamically, okay? So just responding to changing requirements again, the flexibility to add new hardware as you need it and then scale down when you don't need it. High availability, okay, partly through the replication and this distributed systems that you can build. And low cost, basically you want to keep things cheap. If you want to get yourself a big DB2 database or a big Oracle database, you need big hardware to run that. With these things, it's commodity hardware, off-the-shelf stuff. Just scale out horizontally as you need to. Okay. Security and vulnerability. Okay, now one can say a lot about this. So how do these systems fare? Well, basically none. There's no security. Or very little. You can pay for enterprise versions of these products that have better security. Okay, so if you go to DataStax, for example, they have Cassandra Enterprise Edition, which has got some strong security features. Mongo have recently introduced some strong security features. But generally, these products tend to be pretty weak in the security area. So, here's something about Mongo. Basically, they're saying, run everything in a trusted environment. Okay. Similarly for CouchDB, basically anyone can do anything, which could be a good thing. Often it's not, and relax. Redis, same thing here. Just be careful. Protect your TCP ports and Unix sockets from the outside world because somebody gets in, they'll have access to everything. Your password itself may not be enough. Now you've heard of Sql injection attacks. Well, there are no Sql injection attacks as well. Okay, so these systems are vulnerable. Okay, just because it's NoSQL doesn't make them invulnerable. There are various types of attacks. Okay, again at the back of the slide deck, I've provided links to various references, some places you can go at to get more information. Understand the vulnerabilities and consequences. It may be that these vulnerabilities and consequences don't affect you at all. Particularly what you're building or what you're trying to develop. It could well be the case. Now, unfortunately, if you happen to be the most popular product, people are out to get you. And Mongo suffers from this more than I think the others because it is so popular. So there is work, lots of stuff out there showing limitations and problems and the types of attacks that you can run against it. And again, there are some issues as well with certain programming languages that you're using, PHP for example, or if you're doing server-side JavaScript. Again, be careful of those things. Polyglot persistence, very, very important kind of concept. It's this notion that what you're trying to do is effectively just use products together. Okay, so these products could be very, very good for specific problems, whether it happens to be a shopping cart, for example, or analytics, or a product catalog. You might find that one of these products suits that problem case very well. But then in your overall kind of big picture, if you like, your overall architecture, you're able to combine these to build your system. This is taken from Martin Fowler. But this notion has actually been around for quite a long time. It's not something new. There are companies out there doing this kind of thing. Okay, so here's some examples. So Disney, Interactive Mediums, Mendeley, Netflix, Twitter, and so on. And some of these cases are actually documented and written. The important thing to remember is that if you're going to go down this route, you are going to need specialist skills in each of those products. Product specialization requires developer knowledge and skills for each platform. Because if you want to use those products effectively, you need to have the skills, understand how they work. And not only that, but understand how does all of this work together effectively as well. One approach that Disney took was to build this kind of public API as well, partly to protect their system. And here's something from them. It says, in some cases, the team decided to hide the platform's complexity from users, not to facilitate its use, but to keep loose cannon developers from doing something crazy that could take down the whole cluster. How many of you are loose cannon developers here, by the way? Anyone? Anyone brave enough to admit it? Okay, one person. Okay. So, it's very easy to make a simple mistake and it could bring down the entire cluster. So to guard against that, take some precautions. And what did Disney do? They kind of built a layer, if you like. So you're talking against the layer, you're developing against the layer talks to the back end, whatever is there. The flexibility that this provides is that if you find a particular NoSQL product is not suiting your needs anymore because your business needs have changed or you have some problem with it, you can swap it out and it doesn't matter. There are other ways to do this as well. I think there's an Eclipse project, Eclipse Link I think it's called, plus there are some other commercial products out there that will support this kind of thing too. Okay. Benchmarks and performance, quickly, industry standard benchmarks, there's really only one thing that's been widely used and adopted out there, and that came from some work undertaken at Yahoo a couple of years ago called the Yahoo Cloud Serving Benchmark. They tested a couple of these products originally, Cassandra, HBase, Yahoo's Peanuts, Sharded MySQL. So you can get hold of the slide deck and the research paper from Yahoo's website. Okay, just search on this, it'll take you straight to the link. Two things they were looking at is tier one, called performance, okay? So latency by increasing server load, and then how scalable is a product by increasing the number of servers, how does that improve the scalability? So as I said, the research paper, slide deck, Altoras, some of you may have heard of them. They did a very nice analysis and published a 50-plus page report, which I think is going to be updated very soon as well. That's a very nice read. If you have time, have a look at that. Thumbtack, which is based in New York, the consulting company, they did a whole bunch of work trying to look at these products, try to test them in certain conditions, and to stress them a little bit further than I think the Yahoo benchmark did. Again, there's a over 40-page report. I think they've actually published 2 reports. Again, have a look at that in your time, and that's very useful stuff to look at. Other people have done stuff out there as well, and don't be, one argument that I often see is the NoSQL vendors will claim they are immensely faster than relational. Well, it depends, Depends what tuning you've done, what's the use case, the access parts. There are so many degrees of freedom. There's so many variables that can impact performance. This was done by some researchers a couple of years ago, and they looked at Hive versus Parallel Data Warehouse and MongoDB versus SQL Server. And what they found, certainly for the work that they did, was generally that the NoSQL products didn't do as well as the claims were. They were behind relational systems in performance. For the graph stuff, have a look at this. This is very useful. LDBC, Linked Data Benchmark Council, who are working on benchmarks for graph and RDF systems. And something which I came across very, very recently, this is awesome, and I don't use that word very often. It's called the Jepson Project. So there's a gentleman called Kyle, okay, who's been working on this in his spare time, and what he's been trying to do is to develop a way to test how many of these, and not just NoSQL systems, but some relational systems as well, I think, as part of his work, how they handle network partitions, okay? So if you've got a network, distributed system across multiple nodes, let's say some part of your system goes down, what is the rest of the system, how is it going to behave? What about your data? Is it going to be consistent or inconsistent or eventually consistent or what? So he was out to evaluate consistency. And he's published a whole bunch of numbers for many of these products. Again, links at the back of the deck. And his conclusions were, don't rely on vendor marketing, product documentation, or pull the plug test. And in fact, he's found problems with many of these NoSQL products. So again, be armed, okay? Have a read of that work. It is very, very good work. It's not often I find something that really grabs my attention. This certainly did very recently. Analytics, various ways that you can interact with these systems. You could do so through some kind of intermediate. Here we can see LucidDB acting as a kind of an intermediate between, I'm never sure how to say it, whether it's Pentaho or Pentaho or something like that, I'm not sure. But it's like Lake Tahoe in the US. I think it's Pentaho. So Pentaho is oblivious to CouchDB, but we can do queries, we can put together reports, and have a look at this product when you have time. It's a free download, okay? Very good support for a number of these NoSQL products. So if you want to query these products, produce reports, this is a great way to do so. And I played around with this a couple of months ago, and it's point and click. You need to do a little bit of typing here and there in terms of getting data in, getting data out. You need to tell it what the format is, but once you've done that, it's just point and click. It will run the queries for you, produce the reports, do the analysis. It's very, very nice. I like this a lot. What about alternatives to NoSQL then? Well, again, if we go back to this, basically there are lots, lots and lots. Something that we hear about a little bit more today is something called NewSQL. So the idea here is that the traditional relational systems, DB2, Oracle, SQL Server, those were designed in a different era. Those were built for different problems a long time ago. Relational is fairly old technology now. The concepts were around for a very long time. Many of these products started life, 30 or more years ago, and therefore, for the kind of problems that we see in terms of the scalability that we need a different approach. So you've got organizations and companies out there who are building systems, so effectively retaining SQL. There's nothing wrong with SQL. It's great as a query language, as a means to get access to data, but let's build new systems that are able to take advantage of the modern hardware that we see today and can scale up in the same way that NewSQL can. So we need more OLTP throughput. We need real-time analytics. We want ACID support, okay? Maybe we don't want base support. Google, for example, have a look at their F1 system, which has been documented. So they built a large distributed system with extensions to SQL and the ability to support ACID transactions because they found that base is just too hard for developers. I mean, that was their take on it. So SQL is good, automatic query optimization. You keep your existing investment in developer skills and tools, all the things that you've paid money for over the years. That's a good thing to keep. Okay, and then one of these products, which I had the chance to play around with, was something called NuoDB. And again, I think there's a version 2 of their technology just came out very recently. So if you're familiar with JDBC, exactly the same. It's all very simple stuff. So it's tables and rows, it's relational. This is just adding these things in dynamically. Select star from people. Okay, it's always standard SQL. I think it's SQL 92 if I'm not mistaken. And then just updates exactly as you would do. Delete, and so on. The other thing is that the relational vendors are not idle. So look at what the relational guys are doing. So Oracle, for example, have a NoSQL product. IBM is supporting JSON and the ability to use Mongo. Okay, it's a recent announcement from them. But keep in mind that they do support not just relational tables, but you can do XML. XML structures can be stored. DB2, for example, can store RDF. Okay, and these are graph-like structures, linked data, triples. And there is a query language as well called Sparkle, which has a standard behind it, W3C. Okay, so mentioned Oracle very briefly. Summer 2 years ago, Oracle published a white paper called Debunking the NoSQL Hype on the left-hand side. By September of the same year, that paper had mysteriously disappeared, and they published a new one called Oracle NoSQL Database. Okay, so if you search around Google Cache, you can still find the first one. Okay, it's gone from Oracle's website, but it's actually a very nice read because they are quite critical of the NoSQL movement when they wrote it, and then a few months later, of course, they decide, well, they want a piece of the action, they want a slice of the cake, so they bring out their own product, which I think they actually had for some time. Okay, so we're a little bit ahead of schedule, but just to summarize, and then maybe there's a chance for a bit of interaction as well, some questions and things, and then again, I can show you some of the resources as well that would be useful, I think, for you. So, over time, we see this kind of pattern of behavior. So, go back in time, it's this specialization versus generalization. Kicks ISAM, move to relational, object databases, we move back to relational, OLAP and cubes, back to relational. Today, of course, it's NoSQL is the next big thing. Whether or not we are really, where it says today, we are actually at that point, I don't know. I think it's kind of hard to tell. It's this notion of structured versus unstructured or semi-structured data. So relational, very, very good if you know your format, if you know the structure, if you know exactly how you're going to access stuff. Unstructured, semi-structured tends to be better suited for the NoSQL guys, but keep in mind that the relational guys are not going to take this lying down. They will add NoSQL capabilities to their products exactly the same way 10 years ago they added XML capabilities, exactly the same way 20 years ago they added object capabilities. There is this kind of idea of this relational versus NoSQL toolbox. I think it's a nice idea on paper. In practice, I think it's kind of tough to do because remember, these products are very, very different, these NoSQL products, very different in capability, features, functions, architectures. They are designed for different problems, and there's just so many of them. So probably what you'll do often, I think, on many business projects is that you may well use a relational system, report writing, this structured data that you have, or it could be a legacy system. There's no way you can get rid of it. You have to look for the business value. But at the same time, what you'll probably do is augment it or support it with one or two NoSQL products as well. Could be a graph database, might be a document database. And in fact, one of the links, which I'll show you very, very shortly, is a free book, over 280 pages, I think, just published by Microsoft, which shows how to build Polyglot applications. Okay, it's a free PDF download written by a bunch of guys at Microsoft. And I haven't had time to read it in detail, but it goes through and discusses various scenarios and shows you, well, if you're going to be doing documents, here's how you could use a document database, and here's how you could use it with SQL Server, and so on, Okay, so, as I said before, it's tough. I mean, all that quote is doing is just saying it's hard comparing relational with NoSQL because NoSQL, I mean, what does it really mean? You know, what are you referring to? Are you referring to document databases, key value stores, or something else? You know, it's just an umbrella term, a very generic term, and doing this kind of comparison is hard. The other thing is that often they're designed for different problems as well. So you see the overlap in the middle there is okay, it's not big, but it's not particularly small. So on the one side, your relational is still going to be very, very good for many problems. On the other side, NoSQL is going to be good for very problems. It's probably going to be the case that there will be a small overlap between the two. And for that overlap, there may be cases where you will swap out relational for something else. That might work. Some important limitations, issues to think about, things like transactions, not very well supported in these products, depends. Things like isolation levels, those of you who've worked with relational, I think you'll understand what that means. You know, if you can live in a base world with eventual consistency, it could work very well for you. You know, that might be exactly how your problem is addressed. Limited forms of access, okay? There are proprietary interfaces. Often you can't do things like joins, for example, which can be very useful to discover new information. Large clusters, failover, security, you know, there are things to think about and be aware of. Of course, lots of choices too, things to worry about there. We've got, you know, vendors producing lots of charts showing where they are placed, but this one I came across from VaultDB, which is a nice one, because what it shows you is right in the middle you have NoSQL, but if you look around it, you know, you've got Hadoop, data warehouse, traditional RDBMS. You can see that transactional or analytic, depending on your problem type, you know, NoSQL is going to be good for a certain class of problems. Understand your use case, okay? So this is from a survey a couple of years ago. I'm not sure if you can read the numbers there, and I apologize if you can't, but the second biggest reason that people as part of this survey picked Mongo as their product of choice was because it matched their use case. The number one reason was ease of use, okay? They must have been talking to developers, I think. Okay, understand vendor speak, okay? This is great advice. So if the vendor says it's the biggest in the world, what it means is it's the biggest one they've got. If they say it's the biggest in the universe, it's the biggest one they've got. If they say there's no limit to, what it means it's untested, but they don't mind you try it, okay? A new and unique feature, something the competition has had for ages. Currently available feature, they're about to start beta testing. Planned feature, something the competition has that they wish they had that they might have one day. Highly distributed international offices, okay? Engineered for robustness, comes in a tough box, okay? This is from 1994, by the way. Bloor research, okay? 10 years ago, I poked fun at the XML database vendors with exactly the same chart. I suspect if I'm still active in 10 years' time, whatever new thing comes along then, I bet I'll be showing the same chart then. So 10 years' time, if there's another code-centric event here in Serbia, and I get invited, perhaps you know, you guys will be a little bit older and wiser, may have some gray hairs too, that you'll get to see the same chart. Okay, so now I hope I've not left you with too much of a negative impression. What I've tried to do is to give you the other side of the story, if you like, because a lot of these issues are not discussed by the vendors for obvious reasons. I mean, they're in the business to make money. They want to sell their software, they want to sell their services, as all vendors do. I work for Hortonworks. We do the same, okay? It's the same for all companies. We need to make money. You know, that's how we invest and grow. But the thing is, you know, my goal here was to try to make you aware of a few issues in terms of the skills, product selection, the variety, give you some resources and things to think about. This is from Tim Berglund, very, very respected gentleman, very active in the Git and other open source communities. So what he's saying is that we are clearly in the phase of a new technology adoption in which the category is hyped, its benefits overpromised, its limitations poorly understood, and its value oversold, okay? So that's quite strong. I partly agree with that. I think it's a little bit too strong because I think there is real value in these products and they can really help you with certain business problems. Otherwise, people wouldn't be using them, right? There's plenty of documented examples. You know, go to their websites and you'll find lots of case studies from customers who are successfully using this technology, which means that, yes, it's a good thing. Okay, now, quickly, let's skip this. Contact details, that doesn't matter. You can find this later on. I'll skip this. Let me quickly just cover resources. Just got a couple of minutes to do so. So there's a little bit of work there about the first ever NoSQL meetup. Worth having a look at that, just to understand the history and the reasons why this technology developed, okay? There's a roadshow that's been running around in Europe for a while. Pavlo has presented at a couple of these late last year. I think he's been active this year as well. I think the next one is due in Amsterdam end of this month, and then you've got one in London in November. An entire day of NoSQL, if that's what you're interested in. A couple of websites to go to, okay? So these are very good places to get, essentially look for the best places that you can find huge amounts of resources and information. Here is that free book from Microsoft, okay? So it's called Data Access for Highly Scalable Solutions Using SQL, NoSQL, and Polyglot Persistence, okay? So it's over 280 pages, I think, and it's free. It's a PDF download. Fabulous read, I think. I've just briefly looked at it, and it looks like a very, very good. First time someone has done something like this with some interesting patterns and things to look at. Lots of other books as well, so you can get some free stuff on Mongo and Redis, but these are a bit dated, okay? Keep that in mind. Products don't stand still, they move on. Free book on CouchDB, there's something on React as well, which you can get hold of. Performance tips for using Redis, again, PDF download. Here is the thing about free training that I was mentioning a little bit earlier on. Okay, so go to education.mongodb.com. They run free courses for developers, okay? So if you're a PHP developer, or you're a Java developer, or you're using Node.js, they've got 3 courses available. And then if you want to do a DBA course as well, there's a DBA course available as well. And, but I mean, all I would say there is if you haven't taken one of these courses before, it does require quite a lot of investment on your part, okay? You have to watch the videos, you do the quizzes, you do the homework each week. If you've done things like Coursera or something like that, this is very similar. And it's a 7-week investment of your time. And I found that I often put in far more time than they recommended, simply because I'm rusty. My programming language skills were rusty when I started. Therefore, it took me a little bit of time just to get up to speed. But once I'd done that, it was fairly easy going. And at the moment, nobody else is doing this, which surprises me. Kudos to the Mongo people. Lots of articles, there's references to white paper, product selection, okay? So there's some links on helping you, advising you in terms of what you can look at in terms of picking the right product for your use case. And a whole bunch of these references and some case studies that I found as well on the web. You can read about how companies successfully use these. And these are independent, by the way, from those that you will find on vendor websites. There's also negative NoSQL comments out there as well. Again, just for the sake of completeness, read this stuff as well to keep a balanced view of what's happening there. Not everything works out all the time, which happens. Technology sometimes doesn't work the way you expected, and you can make mistakes. These things happen. Security, okay, so references on security, things like injection attacks, how these products can improve security. You can get some level of better security with the kind of enterprise versions of some of these products now, but generally it's very weak at the moment. Needs to improve. Polyglot persistence. Okay, thank you very much. Okay, so we're just about to wrap up then. Some references there. Benchmarks, so I've got a whole load of benchmark references, the Thumbtack, there's various things that I think you can find published at major database conferences as well. Good stuff to read again, just to keep up to date. This is the stress testing one, very, very useful to have a look at this. Something published in InfoQ, testing the partition tolerance of Postgres, Redis, MongoDB, React. Fabulous article there, The Man Who Tortures Databases. I think that was the very good read. Analytics, okay, so various architectures, looking at the types of products that support this. And then the rest of this, I think, just things that I've used throughout this presentation. Oh, and if you want some jokes and humor as well, I've got a couple of references there. So you can learn these jokes, and then next time you go to a party, you can tell your friends a good NoSQL joke, and they'll think it's hilarious. So Okay, and that's it. So I think I'm out of time. Do we have a couple of minutes for any questions? I think we've got, so any questions, issues, concerns? Keep in mind that this is my kind of view on this, okay? So it doesn't represent Hortonworks in any way. It's simply a personal journey that I started beginning of last year to try and look at this technology and things that I found across the way. But as I said, I think a lot of the key to this are things like skills, making sure you have skilled people on your project, and checking that you've picked the product that is best suited for the problem that you have. And that's not easy to do, I think. Sometimes it may be obvious, sometimes not. But I think we have time. Any questions? Yes, gentlemen.
You didn't mention anything about the Gui tools that we can use for that.
Right. Okay, so the gentleman was asking about Gui tools. I think there are a few graphical tools for management and monitoring. So certainly out of the box, if you get Cassandra, for example, you get a nice graphical interface. It's a web-based tool that allows you to look at what's running and be able to do some configuration. Sorry?
Is it running on any platform or is it
No, it's web-based, so it will run anywhere. You just point it to the port number and whatever machine you're running, and it will be able to display the information. And I think it's very similar for Neo as well. You've got a graphical tool which can give you even access to the data. So you can point and click at a node, and then it will expand out that node to show you everything else it's connected to. And then you have the ability also to, within the tool, to be able to type in Cypher queries and to actually execute and run those. Now, given that a lot of these products are open source, invariably people have developed open source tools to go around those. So there are tools to do, whereas traditionally you might do a lot of these things on the command line, for example, in a Unix environment. There are graphical tools that will take that a step further for you, give you some flexibility and ease of use. It depends. I mean, I like graphical tools from one perspective because I think they can be very useful. I do less command line typing now, but I find that a lot of sysadmins still prefer the command line interfaces and tools at that level. But I think certainly you'll find that there's a wealth of open source projects out there that are developing graphical tools, not just for management and administration, but hopefully the other things that we'd like to see as well. So being able to build our graphical models, perhaps have the code generation done for us as well. So we worry less about the back end and we worry more about our business problem. How can we represent it and then have that stored and for us automatically? I wouldn't be surprised if there are Eclipse plugins out there as well. But that's a very good question, and thank you for highlighting that. I think that's a weakness of my presentation, something that I will try to improve and look at those tools in time. I hope that was okay. Okay, yes, question.
Is there some mechanism in MongoDB or non-SQL DBs like procedures that store procedures that are in normal Oracle databases or DB2?
Okay. Okay, so if I understood the gist of it, so do we have something similar to the idea of stored procedures within NoSQL database systems? I think there's nothing to stop you writing your, your code in a way that could be the equivalent of a stored procedure. You can write some Java code, for example. You can package that up. It's a piece of business functionality. I mean, in all intents and purposes, it behaves like a stored procedure. I think this is the way that many of the relational guys address this issue as well in terms of adding functionality which the core engine doesn't support. How can we extend that? We can extend it by writing our own code and just simply call that code from wherever we want to. Again, I think that what they're trying to do is to keep it simple, keep it very much like the programming language that you're using. And if the language supports this notion of packages, if you like, and just being able to write bits of business functionality, just point to it wherever in Java, for example, include that the jar file in your class path. You can call it just the way that. But I think there's nothing beyond that. I might be wrong. Cassandra perhaps might do so. I mean, some of these products that tend to be a little bit closer to the relational world, I think, tend to do that kind of thing better than I think those that are further away. So with a key value store, I think you wouldn't find that thing. Okay. Aggregation.
Natural way to do it on the server side
Yes.
where the data is.
Yes.
And I think even MapReduce.
Yes, that's right. As the gentleman was saying, I mean, you can do MapReduce on MongoDB if you want to. And the aggregation framework, which mentioned some time ago, it's a great way to query the database system. And if you understand Unix and pipes and pipelines and those kind of things, I think you'll very easily adapt to it. It's something that they developed over a period of time to be able to do the filtering and the being able to query your large data sets and narrow it down to exactly what you want. And I think even with Couchbase, for example, they've announced something recently called N1QL, which is a kind of a SQL-like query language. So that could be very useful to look into. Okay, are we out of time? I think we're out of time. All right. Okay, well, I suspect you guys have had enough. So, I'm probably what's standing between you and lunch. So I'll be around for a little while. Okay, please grab me if you want to. And the slide deck will go to the organizers, and they'll put it up on the website. My contact details, all other information is on there. Feel free to drop me an email. Grab me during the lunch break as well if there's anything I can help you with. I hope it's been useful. I hope you've enjoyed this conference. Okay, again, my thanks to the organizers for inviting me. And it's been a fabulous event. It's my first trip in Serbia. Sadly, I'm only here for one day. Next time maybe I'll bring my wife with me, so we have a chance to tour this wonderful country as well. Never seen this part of the world before, but enjoy the rest of the conference, and happy coding with your next NoSQL project. Okay, thank you. All right.